for this video, we're going to talk about question number 1, part A. Explain the fixed point iteration method by demonstrating the root of an equation fx is equals to x to the power 2 minus x minus y is equals to 0. Demonstrate graphically convergent, divergent and loop situation while choosing gx. Prepare a table for various choice of gx and decide gx that is convergent for given x. So firstly we would take our equation that is given. Let fx is equals to x2 minus x1 x to the power 2 minus x minus 1 where when we put a 1 in this equation, I mean in the place of x we put 1, we would get a negative value, and if we put 2 in the place of x, we get a positive value. So we can conclude from this that our root is between x is equals to 1 and x is equals to 2. So for now we can take a median value of 1.5. Now we would just take x to the power 2 is equals to x plus 1 and get a value for x. Now as you can see here, I have done that. This is what we to make a uh, a form like let me write this here. X is equals to okay. So we could say that I have my goal was to make such a kind of equation. I mean such a kind of form. So I firstly took the x square to the left side and took all the terms other than x square to the right side, and then found the value of x and now we could say that x is equals to root of x plus 1. Now other than this, we could approach another method. I mean we could take the x here, we could take the either way we could have another way of finding the value of x. And so as you can see here, there are many gx here. The gx is been like is been taken from here only. The one in one process I've shown you. The other three are taken from that, and that's this from that equation only. And so after taking all the gx value, 1 by x plus 1, 1 x plus 1, x to the power 2 minus 1, and this is all the gx that we know of. And after this we could say that we have to take the derivative of these gx that you are getting familiar with. That is root of x plus 1 is giving a derivative of half root x plus 1. And so supposedly every one of these gx has given a derivative. So we have two columns, that is gx and derivative of gx. After seeing this, we would put the value of 1 in the derivative of gx, and through that we could conclude this that the first uh, value was less than 1, then the next value was higher than 1, the next value is higher than 1 and it was equal to 1, and so on. We could see that. Then we would take the value of 2 and put it in the derivative of gx, and again we could summarize the whole thing and say that the values that we were getting is lesser than 1, and 1 was equal to and higher greater than 1, then the other one was lesser than 1 again, and lastly uh, higher than 1. You could say this was our uh, summarized equation till now. Okay, so for the selection of correct gx, for the selection of correct gx, whenever we are talking about fixed point iteration, it should always be, I mean, the derivative of gx should always be lesser than 1. And if somehow multiple value of g are lesser than 1, choose the least one. So make sure that your derivative of gx should be always less than 1. And so after making the table in the last slide, we now uh, take the divergent and convergent uh, table. And so here you again have your gx with the derivative of gx. We have concluded the value through putting all the values in the gx, and it was summarized in here. As I have already said that derivative of gx should always be less than 1, and so when it is 1 less than 1, it is always convergent. Okay, and so even if and as you can see here, the both the values are either equal to 1 or either lesser than 1, and so or greater than 1, so the answer is divergent. Even if one of them is lesser than 1 and one of them is uh, greater than 1, still the answer would be divergent. At both the cases, the gx derivative of gx should be less than 1, and so we can calculate the last one too, which was divergent. And after seeing this, we could get our gx. We could finally calculate our gx, which is to be taken as a fixed point in the iteration of gx is equals to root of x plus 1. We have firstly took our x naught is equals to 1.5. Now x naught, where did the x naught come from? The x naught came from the first the median value that we have taken in earlier part of the video. And so after taking the x naught, we would now conclude with our x1 is equals to root of 1.5 plus 1, then just calculated which was root of 2.5, which gave us an answer of 1.5811. Again, we would take the 1.5811, which is now calculated as a next iteration of as a next term for our iteration, and so that's how we would go for x2 as well. Then we would take this 1.6065 in the next iteration as a term and calculate for x3, which was 1.6144, till x6 you could find that 1.6176 plus 1. Now you can see that the values have started converging. As you can see, the error between x5 and x6 is about 0.0005, and so after getting another iteration, you could see that the error between both the values, I mean the x6 values and the x7 values, is 0.001, and with that we can conclude that the root of our function is 1.6176. Question number 1, part B. Write the algorithm for finding the root of fx is equals to x2 minus x1 x minus 1 is equals to 0 using the fixed point iteration method. Now we already found the root from here. We have already found the root. As you can see, I have already explained this. And so from this we can create our algorithm. So firstly we have to start, then run a loop for defining the function fx. Now we need to have a fx to have a fixed point in the iteration, and the fx is required. So we firstly define our fx, then define our gx. Obviously we need to have a gx to get the we need to have our gx for iteration, and so we had our gx here as well, as you can see. And so for this again we have found, after finding out the gx, we have which is obtained from fx is equals to 0, we have to put the fx is equals to 0 such that our x is equals to gx value came. So when I first started this video, I have already shown you that this was my way of uh, finding the x is equals to gx form, and that's how we found all the gx in this table. And that in the same way uh, we have to find the x is equals to gx so that I can create my table and make sure that our derivative of gx that we are going to make is always less than 1. And after doing that, we have to choose an initial guess. Obviously initial guess, the median value that I have took, which was 1.5 for this, and then an error e, a maximum iteration n. Now iteration is the number of times number of times the x is we're gonna formulate the answer. And so after doing that, we have to initialize the initial iteration counter to step is equals to 1. So after doing this, we firstly have to start with the gx. We have found the gx, then we have to take a median value, that was the initial guess, then e, and a iteration. Now the iteration that we have took, we have to take it to a counter which was for step 1, as it would be the first iteration. After doing that, we would calculate the x1 is equals to gx naught, gx0. Now that's the same thing that we did here. We took the x0 is equals to 1.5, and so now we were calculating x1 is equals to g of x0, and so in the same manner we would calculate this step. Then after doing this, we would increment the iteration counter by step is equals to step plus 1. After doing this, if step is greater than n, if our step is greater than n, just print not divergent. It is actually, you can print divergent, or you can just say either you can say not convergent, or either you can say just write divergent. And after doing this, go to if it is not divergent, if it is not convergent, then go to the step 12, or otherwise you have to go to the step 10. Then we have to set x0 is equals to x1 for the next iteration. For the next iteration, we have to set x0 is equals to 1. That firstly, we had our 1.5, which we took from here and put it in the gx function, and then after calculating the first value, we have took that term for formulating our next term. I mean, we have taken the x1 to formulate our x2, and so after doing that, so as you can see, This was the point of writing the step, which was we have to set this x0 is equals to x1. After doing this, if the function x1 is greater than e, then go to step 6. If it is greater than e, then again we have to calculate, and if it is not greater than the e, you have to firstly initiate your e as well. And so if after doing that you can go for this, and so otherwise you just have to display the x1 as the root, and with that we would stop the algorithm. With this, the fixed point iteration method is we have found the root for our equation, that was fx is equals to x to the power 2 minus x minus 1 is equals to 0.